Hello, this is Nishat. I'll be telling you what happens if we get a repeated root. Now, so I have mentioned the main equation again, which is like x squared y double prime plus ax y prime plus by equals 0. And in order to solve that, like the earlier rule, we have to put y equals x to the power m here. And we get something like m squared plus a minus 1m plus b equals 0. Now, suppose we get only one solution, that is like m equals half 1 minus a. So our first solution will be y1 equals x to the power half 1 minus a. Now, we need to find one more solution. We take another root as y equals u y1. Now, we differentiate both sides of that root. And we get y prime equals u y1 prime plus u prime y1, and y double prime equals u y1 double prime plus 2 u prime y1 prime plus u double prime y1. Now, if we put them both in the main equation, we get something like this. Okay. Now, the terms that contains a u with it, like this term here, you'll get a u, and then there is another term here, and like this there is another term here. So if we factor out u from this term, we get an equation like this. Okay. And next we say that this term is equals to 0 because y is a solution of the main equation. Y1 is a solution. So what we left with is this term. Okay, the rest of the equation, okay, equals 0. Now, if we know y1 is half 1 minus a, so if we plug in it in this equation, we get something like that. So if we divide the above equation by x to the power half 3 minus a, we get something like this. Okay, and then we reduce it to u prime plus x u double prime equals 0. And now we need to make this one first order ODE because that is easier to solve. So we suppose u prime is equals to capital U, and we plug in that in the equation. And after doing a separation of variable method, we receive something like this. Capital U equals 1 by x, and that's equals small u prime. And we all know that small u prime is equals 1 by x. So if we integrate it again, do the ODE again, we receive something like this. U equals ln x. And since another root was y equals u y1, we plug the u's value in this equation and we get this. So our complete solution will be y equals c1 x to the power m plus c2 x to the power m ln x. Now we are doing an example. So basically this is our example: x squared y double prime minus xy prime plus y equals 0, where these are our boundary conditions. Y of 1 equals 1, y prime of 1 equals 2. And to solve this equation, we do the same thing again. We go to y equals x to the power m, and we get something of this kind. Yeah, and we can say a is equals minus 1 and b equals 1 from this equation. Okay, so if we reduce it, we get m squared minus 2m plus 1. Here, if we solve this equation, we get m equals 1. So 1 is a double root. Now, so we get the general solution as y equals c1x plus c2x ln x. And if we do differentiation on like both sides, we receive this thing. And after doing this, if we plug in our boundary conditions, we get c1 plus c1 equals 1 and c2 equals 1. And after plugging it in the like general solution, yeah, we get something like this: y equals x plus x ln x. So I hope you all have understood the real repeated root. And the rest part of the presentation will be continued by Rebecca.